Welcome back to Edupedia World. In the last lecture, we read about levers. Today we will discuss about another simple machine which is called as an inclined plane. We will understand what an inclined plane is, and then we will see certain relations and certain formulations related to inclined plane, and finally we will do a numerical to wrap up the chapter of inclined plane. Let us get started. It is a matter of common experience that we use a sloped plank to lift a load to a higher height. Like if you want to load a truck, you use a plank to move the things into the truck. This helps us by letting us move the object to a higher height by application of a smaller force. That is, the effort required to lift the object to that height through a plank is relatively less compared to if we were trying to lift the load directly vertically upwards into the truck or into at that height. So this sloped plank, which basically reduces our effort to move an object to a higher level, is termed as an inclined plane. So inclined plane can be defined as a sloping surface, and what does it do? It is a simple machine, a sloping surface which acts as a simple machine, and it helps reduce the effort required to lift a load. Therefore, whose mechanical advantage is greater than 1. Why so? Because the effort required is less than the load, and mechanical advantage is the load upon effort. Therefore, this inclined plane always has a mechanical advantage greater than 1. Now, though the effort required to move the object using an inclined plane is less than it would have required to directly lift the object, the work done in both the cases is same. In fact, the work done in the case of inclined plane can be more if there is friction caused by the inclined plane. Then additional work needs to be done to overcome the frictional forces. But in an ideal scenario, when there is no friction, then the work is not changing. The work required to move an object to a height h through an inclined plane is same as the work required to lift an object to a height h. So that is an important point. Same work as direct lifting. In case of ideal scenario, what is ideal? Friction is 0. So now let us derive the mechanical advantage for an inclined plane with this concept in mind. This is something like an inclined plane. It is sloped at an angle theta to the horizontal. And what does this do? This lifts the object to a height h, and let this length of the inclined plane be L. L is the length of the inclined plane. Now let me say that this is a load L. The load is L, which will be acting directly downwards. This is capital L. This is the load, and obviously the load will try to bring the body down the incline. So we have to apply a force up the incline to keep it moving upwards. Now that will be the externally applied effort, or the effort which we are applying to do the task, to carry out the task. So this is a simple scenario of the inclined plane. That is, the plane is inclined at an angle theta, and it has to move a length L in order to achieve the height h. Now, if we take the component of L, if we break the component along the plane and perpendicular to the plane, then it will be something like this. Perpendicular to the plane should be this, and along the plane should be this. Now what will be the magnitude of this force and this component of load? To find out that, we need to see what is this angle. We know that this angle is theta. This is perpendicular, so here it will create a 90 degree. This will be 90 minus theta. Therefore, this angle turns out to be theta. This angle turns out to be theta. And when this is theta, this is L, then this is L cos theta. This component is L cos theta. This is theta, then this component is L sin theta. I hope you understand how I broke the components of load. It's simple geometry. We found that since this is theta, this angle will also be theta, and we know that the cos theta is adjacent side upon hypotenuse. So the adjacent side will be hypotenuse times cos theta. And we know that sin theta is opposite side, this side, by hypotenuse. And this side is same as this side. So this side turns out to be L times sin theta. Now, if we equate the forces which is making the body move in the direction of the plane, a thing to note is that the effort is exactly equal to the component of the load in this direction. Why? Because only in that case the velocity of the body remains constant. If effort becomes larger than L sin theta, then the body starts to gain speed in this direction. If the effort becomes smaller than L sin theta, then the body will start to slide down the plane. Only when E and L sin theta are equal, then the body will keep on moving along the plane at a constant speed. So for the equilibrium condition, for the condition of constant speed, we get that E is equal to L times sin theta. Now we know that mechanical advantage is defined as the load upon the effort. This is the basic definition of mechanical advantage. Now if we compare this with this, L is the load, E is the effort. So load upon effort, from here we can say that load upon effort is 1 upon sine of theta. So the mechanical advantage turns out to be 1 upon sine of theta. Clearly we see that the mechanical advantage has to be always greater than or equal to 1. Why so? That is so because sine theta has a maximum value of 1. When sine theta is 1, then mechanical advantage is 1. When sine theta is anything but any value less than 1, then the mechanical advantage becomes greater than 1. Therefore, the mechanical advantage of an inclined plane is always greater than 1 and equal to 1 in the case when theta is 0, rather when theta is 90 degree, then it is equivalent to just lifting the load directly. Then the concept of inclined plane no longer exists for theta equal to 90 degree. So this is an important derivation, that mechanical advantage is 1 upon sine theta. Now another important thing is that we can convert this in terms of length and height. How so? Using this, we know that sine theta is opposite side upon hypotenuse. So opposite side is h upon hypotenuse is the length of the plane, that is L. This two together implies that mechanical advantage is 1 upon sine of theta, which is equal to L upon h. So the mechanical advantage is the length of incline upon the height to be attained. So we can increase the mechanical advantage of a plane by decreasing the theta. In other words, if we use up a larger length to cover the same height, then we can do it by applying less effort, since that results in a higher mechanical advantage. Now the velocity ratio, if we want to calculate the velocity ratio, let us do it here. Velocity ratio, what is the definition of velocity ratio? Velocity ratio is defined as the distance the effort moves upon distance the load moves. What is the distance the effort moves here? The distance the effort moves is the whole length of the plane from here to here, that is small l. And what is the distance that the load moves? The load moves from the bottom to the top. Since the load is in this direction, we have to consider this direction, the movement along this direction. So the movement is from here to here, that is h. So the velocity ratio turns out to be L upon h2. And efficiency is mechanical advantage upon velocity ratio from our previous lectures, and that turns out to be 1. I hope you understand the significance of this. What this tells us is that the body can be moved by applying a lesser force. That is, the effort required is less, and the efficiency in case of a frictionless incline, which is the case at hand here, turns out to be exactly equal to 1 or 100%. Now, what would be the case if there were a friction? It is beyond the syllabus, but I'll just briefly mention it. What will happen is that when there is friction, then you have to apply an additional effort. The force for effort will be more because a little amount of effort will be consumed to overcome the frictional forces. As a result, what will happen is, for the mechanical advantage, since the effort will have to increase, the mechanical advantage will decrease. Then, to maintain the same effort to move the load, we have an alternative option to reduce the theta. By reducing the theta, we can keep the same E and move the block upwards. Okay, so much for the theory. Let us see an example. This question says that we have a box of mass 100 kg and it is moved up by incline of length 10 meter. The slope of the incline is said to be 30 degrees. So what is the complete scenario here? This is our load. This is the incline, that is 30 degree. The length is 10 meter. 10 meter length. We don't know the height h. So the first thing, let us find this height h. If we calculate sine 30 degree, sine 30, that is height upon this opposite side upon hypotenuse, that is height by 10. Sine 30 is half, is equal to h upon 10. This gives us h is equal to 5 meter. So this height is 5 meter. We will need this value further down the question. Now we know that the mass of the block is 100 kg. So this is 100 kg. And the load L will be given by, let me write it down here, L will be mass times gravity, and that will be, gravity is 10 meter per second square, mass is 100, so it will be 100 times 10, that is 1000 Newton. That is the load. Okay, with this information, now let us start solving the question one by one. First part asks us to find a mechanical advantage. We just saw in the theory that the mechanical advantage is L upon H. We can derive this if we don't remember, but this is quite a simple equation to remember. So hopefully you will remember this and directly use it while finding the mechanical advantage. If we use L upon H, we already have been given L as 10 meter and we just found out that H, the height, is 5 meter. So that gives us a mechanical advantage of 2. What this means is that the effort required will be half times the load. Okay, now for the second part, Velocity ratio we saw is the same relation as L upon H, and that will be same as 2. So the velocity ratio is also 2, which means that the load will move twice as fast as the effort. Third part asks us to find the effort. Now we just saw that effort and mechanical advantage has a relation. What is the relation? The relation is that mechanical advantage is load upon effort. This gives us effort is load upon mechanical advantage. The load being 1000 Newton and mechanical advantage being 2, we get the effort required as 500 Newton. So 500 Newton is the effort required to move the block of 100 kg up the incline, instead of 1000 Newton, which would have been required if we directly lifted the box vertically up. So that is, the effort required is being reduced to half. Now the final part, the fourth part, asks us what is the work done. Work done can be found in several ways. I will use the relation effort into the distance in the direction of effort. And to distance in direction of effort is L. So the effort is, as we found out, 500 Newton and L is 10 meter. So the work done is 5000 joule. Alternatively, we could have found work done as mgh, where m is the mass of the body, g is the gravity, and h is the height to which it is lifted. That would give us mass of 100 times 10, and the height would be 5 meter here. It is lifted from here to here, effectively the height, and it gives us the same value of 5000 joule. So we just saw that the work done either directly, that is either through the incline, or if we were to lift it directly, is the same in this case because there is no friction. So to sum it up, we see that the angle kind of decides how much effort is required. If the angle were further less, let's say make it 15 degree, then the effort required would have been furthermore reduced. Why so? Because mechanical advantage is 1 upon sine theta, and mechanical advantage for 15 degree would be higher than for 30 degree, and mechanical advantage being higher reflects as a lesser required effort, because here is mechanical advantage, effort is inversely proportional to mechanical advantage. This more or less covers the whole theory which we saw about inclined plane. The only thing which we missed out here was the efficiency factor, which if we calculate comes out to be 100%, because mechanical advantage and velocity ratio both are 2. Okay, with this we will conclude our lecture on inclined plane. I'm not going to go into further numericals. I hope you practice a few on your own and see how this works out. The next topic we will be covering will be another kind of machine, which is gears. It's used in day-to-day activities. You use gears in your bicycle, in your watches, and whatnot. So let us study gears in our next class. For now, I will take your leave. Have a great day. Goodbye.